Hey guys, welcome back to the channel. This will be our second video in the series where we use ChatGPT to help us design ITBs for my 5.3 liter LS engine. If you missed the first video, the link to the playlist is below, so check it out so you don't miss anything. At the end of our last video, we had pulled our first test print off the printer and removed the supports. So now, let's see how it turned out. So here's the intake after all the supports and everything have been removed, and I printed this low quality because I didn't want to waste a bunch of filament, and this is 20% infill also. I can already see a few areas I'm definitely going to make some revisions in. Yeah, everything turned out really good. All the dimensions are good. The ports are nicely uniform shape. You can see how the transition from the cathedral shape to the 47 millimeter is nice and straight, right down to the valve. Now that we've gotten a start on the main manifold, let's get into our throttle body design. This was the design I came up with first. My main goal with this first print was to check the clearance for the throttle shaft pivot bearing. I wanted a tight fit for the bearing, so I modeled the hole to be the exact diameter of the outer bearing race, 19 millimeters. So here I'm heating up the body at 200 degrees Fahrenheit for 15 minutes so it'll accept the bearings that have been in the freezer overnight. Bearings. Oh, perfect. Perfect.
It works?
Yeah, look. They're in there.
Oh, that's sick.
Now, since this is just a prototype in basic PLA, I will still need to figure out what adjustments will need to be made in the end product print material, but we can cross that bridge when we get there. For now though, let's take a look at a few revisions. Now let's start with our intake manifold. Some revisions that I made from the first print. I think one of the biggest things was I did trim out some material from the base, because if you can see here, this one is more rectangular in shape, and I was able to round off and slim this one off quite a bit, and that really helps bring some things down the dimension wise and also make things look a little bit cleaner. Another thing I did is I added these ports here, which these are for 1/4 inch NPT fittings, and these threads are modeled in. And what I did was I modeled them in the CAD software, but they're kind of loose. And one thing I did learn in the process is I printed this, and this is actually a part from McMaster-Carr. And if you go to their website, you can find 3D models of basically most of the hardware that they carry. So I was able to get this part from their website and 3D print it as a test piece to see how well the threads would print. And this is how they turned out. They are super tight and nice, and I will be applying Teflon tape to this in order to seal better, but they definitely feel a lot nicer than the modeled threads I modeled here. So the next revision will reflect that. And one of the next changes I made was I added a place to mount the fuel rail. And I actually went on Amazon and bought literally the cheapest fuel rail I could find. And it's nice because the locations where this mount are exactly in the center of each cylinder. So this will mount like this here, and I use threaded brass inserts, if you could see there, on a lot of these mounting surfaces, but my bolt was too long and I tried to inset these ones further, so I kind of messed it up, but it was a learning experience. So now I would be able to mount my fuel rail like that if I didn't ruin the bolts. And I was also able to find a document or a STL on EV6 injector. So now I can just print a few of these and kind of use them to check the fit of my injectors and You know, they're loose now because there's no O-ring, but once you add an O-ring to there, the fitment is pretty spot on. And I'm really happy with the way it came out. All my heights and my clearances were good, but like I said, I messed up these holes, so I will need to print an entire new manifold in order to test fit the fuel rail. But so far everything looks like it's gonna fit up quite nicely. Now we'll move on to our throttle bodies. It took me 5 revisions, but now I think I'm finally close to a final product. So this was the first one, and it's simply just missing parts. It's missing bolt holes to bolt it down, and like I said earlier, I just wanted to do this one to check the clearance on the bearing and also the fitment to the rest of the intake manifold. So for these next 4, I was simply trying to get this tube to fit inside of the bore, because ChatGPT actually suggested I use aluminum to line the bore, and what that will do is it'll prevent the throttle plate from wearing out the plastic on the inside when it opens and closes. So it was interesting because I ordered this material and it was supposed to be 51mm OD and 47.4 ID, but it's more like a 50mm and a 47.4. So the inner diameter is correct, but the outer diameter is a little bit smaller. So I don't know if they sent me the wrong thing or what, but this is what I ended up with. But anyway, the first one, it didn't fit. I made some changes. I gave it some bolt holes and added some areas of clearance for the bolts, but also I found out that the bolts wouldn't fit as well because they don't fit in this space. And the next one, I ran out of filament halfway through and it was just too big, which, yeah, see how it slides back and forth on here, and that's no good. And this one, I took it down a few millimeters or fractions of a millimeter and it was too small. But then the final one, literally perfect, almost a press fit. I really do need to bevel the edge, but yeah, perfect press fit, tight fit on there, which is what we're after. And yeah, there's some voids, but they really don't matter. And we'll actually get into how we machine this later on in the series. So hopefully in the next few videos, when we're assembling, we'll machine all these parts. Oh, and I also thought I might add, I also put in a provision for an O-ring seal that will go in there like that. And this is where it'll seal to the base of the intake, and then it's also on the reverse side where it'll seal to the plate that'll eventually be modeled on top that will seal on the intake velocity stack. So quite happy with that fitment, and that'll provide a good seal between the two surfaces. So I just assembled everything that I had on hand. This was just my first design of the intake trumpet, and I'm kind of thinking about changing it because it uses so much material, and I'm probably gonna separate the base from the stack itself just to make things quicker to change in and out. So I'll probably end up putting like some kind of clamp that I might make out of TPU or something here so that I can change them out whenever I need to. But yeah, that's the finished product. I'm actually in the middle of doing a few revisions and then hopefully get these on the press, or on the printer rather, and get a final assembly maybe in the next video. I don't know, we'll see. Depends on how long it takes to print. Well, thanks guys for watching. I'm working on a few revisions now of, hopefully it'll be close to the final design, or at least our first final assembly that we'll be doing on a test engine that we'll be getting in the next couple days. So if you liked this video, please go ahead and subscribe, like, and let me know what you think. When I start assembling everything, I'm probably gonna have a lot of questions for the project and for myself, and some things that I'm gonna be trying to figure out. So it'll be pretty entertaining because we'll have the throttle linkage and more velocity stack tests, but I'm pretty sure we have everything from the intake to the throttle body figured out, and it's just everything above that. I'm just in the stages of figuring out now. But thanks for watching, guys, and gotta get this on the printer, and I'll see you in the next one.